Experiment number 3 is going to be done two ways. We're basically trying to find the pivot point here. So I'm going to select right now the pivot point to be where somewhere in between the mass and the force of the Earth. As you can see on my extended force diagrams, I'm going to call this distance x. Since I know the distance between these two forces is 0.5 meters, I can then call this distance 0.5 minus x. Now I can set up my net torque equation, which is equal to 0. I'm going to have, since the force of the pivot is my pivot point, there's no torque due to the pivot itself. Alright, so I'm going to have the force of the hanging mass here, which is 1.4 times our unknown x minus the force of the Earth on the meter stick times 0.5 minus x. Okay, if I run through the calculus, all that is equal to 0. Ultimately, if I add the force of the Earth times the unknown distance to the other side, I get 1.4 times x is equal to 1 times the quantity 0.5 minus x. So if I distribute the 1 and add 1x to both sides, I get 2.4x is equal to 0.5, where x is equal to 0.208 meters, or about 21 centimeters. Alright, version number 2. I'm going to choose the pivot to be 0 on the meter stick, all the way at the end. And I don't know the distance from the pivot point, but I do know the distance from the force of the Earth, which is a half a meter. Alright, so instead of looking at some of the torques first, I'm going to look at some of the forces. So I know that the sum of the forces exerted on the meter stick will equal 0, which will equal the force of the pivot minus the force of the mass minus the force of the Earth, which would be the force of the pivot minus 1.4 newtons minus 1 newton is equal to 0, or in this case we know the force of the pivot will equal 2.4 newtons. So now around this point here, I'm going to set up the sum of the torques. Alright, so we have the pivot essentially going to exert a counterclockwise torque this way, and the Earth exerting a clockwise torque this way. So we'll have, for the sum of the torques, equal to 0, which would be the force of the pivot times x. Since that's counterclockwise, I'll make that negative, plus the force of the Earth times 0.5 will be positive because that's clockwise. That will equal 0. Or if we add the torque of the pivot to the other side, we get 1 times 0.5 meters is equal to 2.4 newtons times our unknown distance x. If we solve for x, again we get 0.208 meters. The reason we get the same exact answer is because we just use a different point of reference for the pivot. The situation is the same. All the forces and all the torques are balanced. We know it's not rotating. So it doesn't matter what point you could rotate it at. If it's still balanced, the torques and the forces will always equal 0. So that being said, either way it works, and it doesn't matter where you choose your pivot.